The morning of December 22nd, 1944, somewhere in the frozen forests of Belgium, near the town of Stavelot, Oberfeldwebel Kurt Müller sat inside a tank that was not his own, listening to an engine that should not still be running. For the past 6 days, he and his crew had operated this captured American M4 Sherman through some of the harshest winter conditions of the war. They had driven it through snow and mud, through forests and villages, through retreats and skirmishes. The engine, a simple radial design that German intelligence had dismissed as crude American improvisation, started every morning with a single button press and ran all day without complaint. Behind them, scattered across the roads of the Ardennes, lay dozens of German tanks, Panthers with broken transmissions, Panzer IVs with failed final drives, Tigers immobilized by frozen interleaved wheels. The magnificent products of German engineering, defeated not by American guns but by their own complexity. And here, in the commander's position of an enemy tank, Müller confronted a truth that would haunt him for the rest of his life. The Americans had not just built more tanks, they had built better ones. Not better in the ways German propaganda had taught him to measure superiority, not in armor thickness or gun caliber or mechanical sophistication. Better in the only way that actually mattered in war. They kept fighting. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand how Kurt Müller arrived at this moment of recognition, you must first understand what he had been taught to believe. And to understand that belief, you must know where it came from. Müller had entered the Panzerwaffe in the spring of 1941, when German armor was at the height of its reputation. He trained at the Wunsdorf facility south of Berlin, where instructors who had fought in Poland and France taught the next generation of tank commanders. These were men who had witnessed the Blitzkrieg at its most effective, who had seen German armor tear through enemy formations that the previous war's generals had believed impregnable. They spoke of German tanks with a reverence that bordered on religious conviction. His primary instructor, Hauptmann Ernst Dietrich, had commanded a Panzer III during the French campaign. On Müller's first day of training, Dietrich assembled the new recruits in front of a Panzer IV Ausf F and delivered a speech that Müller would remember word for decades. Gentlemen, you are looking at the result of 50 years of German engineering excellence. This machine represents the accumulated knowledge of firms like Krupp, Daimler-Benz, and Maybach companies that have been perfecting steel and engines since before any of you were born. Every component you see has been designed by engineers who understand that war demands perfection. The Russians build tractors and attach guns to them. The British build mobile fortresses that crawl across battlefields at a walking pace. The Americans build automobiles and call them tanks. But we build instruments of war. The technical specifications supported this worldview in ways that seemed irrefutable. The Panzer IV that Müller would eventually command mounted a 75mm Quay K40 gun, capable of penetrating 89mm of armor at 1,000 meters. Its Maybach HL120 engine generated 300 horsepower through a 12-cylinder design that represented the pinnacle of German automotive engineering. The armor protection, 80mm of face-hardened steel on the frontal arc, could defeat most enemy anti-tank weapons at typical combat ranges. These were not propaganda numbers inflated for morale purposes. These were facts, verified in combat from the Atlantic coast to the Caucasus Mountains. Müller's training emphasized not just the operation of these machines, but their underlying philosophy. German tanks were precision instruments, products of a manufacturing tradition that measured tolerances in hundredths of a millimeter. The Maybach engine required careful maintenance and attention to detail, but it delivered smooth, reliable power when properly cared for. The Zahnradfabrik transmission used synchromesh technology that allowed for precise gear changes and optimal power delivery. The torsion bar suspension, designed by engineers from Ferdinand Porsche's design bureau, provided superior ride quality and cross-country performance compared to the crude spring systems used by other nations. Every system reflected this commitment to engineering excellence. The Zeiss optics in the commander's cupola offered clarity and magnification that made target identification possible at ranges where enemy crews were still searching for German positions. The gun-laying mechanisms allowed for precise adjustments measured in fractions of a degree. Even the crew positions were designed with German thoroughness, every control, every gauge, every lever positioned for maximum efficiency based on extensive ergonomic studies. The training manual for the Panzer IV ran to over 400 pages because every system required detailed understanding. The electrical system alone occupied 30 pages, covering everything from the proper maintenance of the Bosch generator to the correct procedure for replacing the various fuses and relays. The transmission section explained not just how to shift gears, but why certain shift patterns were required, what forces were acting on which components, how to recognize early warning signs of wear or damage. This complexity was not seen as a weakness. It was evidence of sophistication, of depth of engineering thought. A British tank crew might learn their machine in a few weeks. A Russian crew might master their 34 in days. But a German Panzer crew trained for months because their machine demanded more, because understanding its systems required genuine technical knowledge, because operating it to its full potential required skill that took time to develop. Müller had seen the results of this sophistication in his first combat action at Kursk in July 1943. His unit, the 3rd Panzer Division, had attacked Soviet positions as part of the southern pincer of Operation Citadel. The German tanks had engaged Soviet armor at ranges that seemed impossible to anyone who had not experienced the clarity of German optics and the precision of German guns. Tiger tanks destroyed 34s at distances exceeding 2,000 meters, picking them off with first-round hits, while Soviet return fire fell short or scattered wide. Panthers, with their long 75mm guns, achieved kill ratios that would have seemed fantastical if they had not been documented in after-action reports. Even Müller's Panzer, IV, the workhorse medium tank of the Wehrmacht, proved superior to the Soviet 34 in direct engagements. The Soviet tactics reflected their material disadvantages. They attacked in mass formations, accepting horrific casualties to close the range, where their numerical advantage could compensate for German technical superiority. Müller had watched waves of Soviet tanks advance across open ground, seen German gunners methodically destroy them one after another, felt the peculiar mixture of awe and horror at what German engineering could accomplish in skilled hands. This was the foundation of belief. Not propaganda, not blind faith, but direct experience of German technological superiority translated into battlefield success. When instructors said German tanks were the finest in the world, they were stating what appeared to be an observable fact. The American Sherman tank appeared in German intelligence briefings starting in late 1942, after the North African landings. The initial assessments were consistent with everything Müller had been taught about American military capabilities. The M4 Sherman was mass-produced in automobile factories by workers who had been building civilian vehicles the previous year. Its armor protection was marginal 51mm on the frontal hull, barely sufficient to stop German 50mm anti-tank guns, and completely inadequate against the long-barreled 75mm weapons mounted on later-model German tanks. Its main armament, a 75mm gun, was capable but unexceptional, lacking the penetrating power of German long-barreled designs. The Sherman's engine told its own story about American design philosophy. The Continental Rhine 75 was an air-cooled radial engine, originally designed for aircraft, simply adapted for tank use with minimal modification. It was the kind of improvisation you would expect from Americans' practical, expedient, prioritizing, availability over optimization. German tank engines were purpose-designed by firms like Maybach, companies with decades of experience building precision engines for demanding applications. The Americans had taken an airplane engine and bolted it into a tank. The production numbers supported the narrative of American industrial crudeness. By mid-1944, American factories had produced over 40,000 Sherman tanks. 40,000. The number itself seemed to prove the point. German factories, working with precision and care, had produced approximately 8,000 Panzer IVs over the same period. The Americans compensated for their lack of sophistication with sheer industrial mass, throwing numbers at problems that German engineering solved through quality. Intelligence officers displayed photographs of American tank factories during training briefings, assembly lines, women workers, tanks rolling off production lines by the dozens each day from facilities that had manufactured automobiles before the war. The contrast with German tank production could not have been starker. German tanks were built by legendary firms Krupp, with its 300-year history of steelmaking, Daimler-Benz, whose engineering excellence had made Mercedes a byword for quality, Henschel, MAN, Wegmann. These were not automobile manufacturers retooled for war production. These were defense contractors with deep expertise in armored vehicle design. The assembly process itself reflected different philosophies. German tanks required skilled workers, men who understood the tolerances and procedures necessary to build precision machinery. Many components were still hand-fitted, adjusted by experienced technicians to ensure optimal performance. American tanks were built like cars, standardized parts, interchangeable components, assembly line workers following simple procedures that required no deep understanding of mechanical engineering. Feldwebel Hans Krauss, who became Müller's gunner in early 1944, had spent time at the Krupp works in Essen before the war. He explained German tank manufacturing to the crew one evening during a maintenance halt. Every transmission is tested before installation. Every engine is run on a test stand. They check tolerances. They verify performance. They ensure that everything meets specifications. It takes time. It requires expertise. But the result is a machine you can trust with your life. And the Americans? Asked Gefreiter Otto Richter, the driver. The Americans build them like tractors. Same part in every tank. No hand-fitting, no individual attention. If a component fails, you throw it away and install another from the warehouse. Like replacing a tire on a truck. This seemed self-evidently inferior. A skilled mechanic adjusting components to perfect tolerances versus an assembly line worker installing standardized parts, which approach would produce a better machine. The answer seemed obvious to anyone with basic understanding of engineering principles. By late 1944, Müller had 3 years of combat experience. He had fought on the Eastern Front, had survived Kursk and the subsequent retreats. His original crew was gone, some dead, some transferred, some broken by what they had witnessed. The current crew were all veterans, men who had seen enough combat to know the difference between propaganda and reality. They understood that the war was going badly. The Soviets had pushed German forces back across hundreds of kilometers. The Anglo-Americans had landed in Normandy and were grinding toward Germany's western borders. The 1,000-year Reich was clearly not going to last 1,000 years. But the material explanation for German setbacks made sense within the framework they had been taught. Germany was fighting a multi-front war against enemies who possessed overwhelming numerical superiority. The Soviet Union had essentially unlimited manpower and vast industrial capacity beyond the Ural Mountains, safe from German bombing. The United States had industrial might that dwarfed Germany's productive capacity. Britain controlled resources from a global empire. Germany was surrounded, outnumbered, outproduced. What Germany still possessed, however, was qualitative superiority. Individual German weapons were better. German tanks, German guns, German tactics, German soldiers, these remained superior to their Allied equivalents. The Wehrmacht was losing because it was being ground down by sheer mass, not because Allied equipment or soldiers were actually better. This was the narrative that preserved meaning in continued resistance. Germany was like Sparta at Thermopylae, outnumbered but not outclassed, facing defeat through numerical superiority rather than through any failure of German capability or quality. The technical data supported this interpretation. Intelligence reports from Normandy documented Sherman tank casualties at rates that shocked even German analysts accustomed to the brutal arithmetic of the Eastern Front. American tank units suffered casualty rates approaching 80% in some engagements. German tank destroyers and anti-tank guns devastated Sherman formations. The joke among German tankers was that Shermans required 5-man crews, 4 to operate the tank, and 1 to replace the whole crew after the tank was knocked out. German tanks, by contrast, achieved favorable exchange ratios even in defeat. A Panzer tank could destroy multiple Shermans before being overwhelmed by numbers or knocked out by flanking fire. A Tiger tank could dominate entire sectors of the battlefield, forcing American armor to avoid engagement or wait for air support. The Germans were losing, yes, but they were losing the way a superior boxer loses to a street brawler who simply absorbs punishment and keeps coming not through any lack of skill, but through exhaustion and accumulating damage. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. What nobody discussed in these assessments was operational availability, or rather, they discussed it in ways that reinforced existing assumptions. Intelligence reports noted that German tanks required extensive maintenance. This was framed as the cost of sophistication precision machinery naturally required more care than crude mass-produced equipment. The daily maintenance routines that consumed 2 to 3 hours of every crew's day were evidence of German thoroughness, of the attention to detail that made German engineering superior. Müller's crew had learned to live with their Panzer IV's temperament the way sailors learn to live with their ship's peculiarities. The transmission required careful shifting technique. If you forced the gears or shifted at incorrect RPM ranges, you could strip teeth or damage synchronizers. The repair would take days if the right parts were available, and by late 1944, the right parts were increasingly not available. So, you learned to shift with mechanical sympathy, listening to the engine, feeling the transmission through the lever, treating it like the precision instrument it was. The interleaved road wheels, a sophisticated suspension design that provided excellent ride quality and off-road performance, had their own demands. The overlapping wheels collected mud, which froze solid in winter temperatures. A Panzer IV with frozen road wheels was immobile until the crew spent hours chipping away ice with whatever tools they could find. The design was brilliant in theory, providing superior ground pressure distribution and smooth ride characteristics. In practice, it was a maintenance nightmare under the conditions of the Eastern Front or a Belgian winter. The Maybach engine needed constant attention. The cooling system was sensitive to contamination. The electrical components were invulnerable to moisture. The fuel injection required periodic adjustment. None of this was seen as a design flaw. It was simply the reality of operating sophisticated machinery under combat conditions. Russian 34s might be crudely built with loose tolerances, but those loose tolerances meant sloppy performance, imprecision, mechanical crudeness. German precision required maintenance, but it delivered superior capability. By December 1944, Müller's unit had been pulled from the Eastern Front and repositioned in the West. They were part of the forces massing for what would become the Ardennes offensive, Hitler's last gamble, a massive armoured thrust through the Belgian forests aimed at splitting the Allied forces and capturing the port of Antwerp. The plan was audacious to the point of desperation, but it represented the kind of bold operational thinking that had won Germany victories in Poland and France. If German armour could achieve surprise, if they could exploit their tactical superiority against inferior American troops still learning the realities of European warfare, perhaps the war could be prolonged, perhaps better peace terms could be negotiated. The mood in Müller's unit was strange. Nobody believed the Reich would win the war in any conventional sense. But perhaps they could avoid total catastrophe. Perhaps they could fight the Western Allies to a stalemate while holding the Soviets at bay. Perhaps something new weapons, political changes in the Allied coalition, simple exhaustion among their enemies would prevent complete destruction. Hope was scarce, but the alternative to hope was surrender or suicide. So men found ways to keep fighting. Müller's Panzer IV had been rebuilt after the Eastern Front campaigns. The transmission was not new but refurbished, assembled from parts cannibalized from destroyed tanks. The engine burned oil not severely enough to be non-functional, but enough that they had to monitor levels carefully. Two of the road wheels had hairline cracks that would eventually require replacement, if replacement wheels could be found. The electrical system was temperamental. The vehicle was, like much of the Wehrmacht by late 1944, functional but worn, held together by mechanical skill and determination. On December 16, 1944, the offensive began. Through snow and fog that grounded Allied aircraft, German armor pushed into the American lines. For the first 3 days, it felt like the old times, like France in 1940. American positions seemed thin, inexperienced. German tanks penetrated deep into American rear areas, prisoners were taken by the thousands, supply dumps were captured. For a brief period, it seemed possible that German tactical excellence might achieve what strategic reality said was impossible. Then the weather cleared, and the American fighter bombers appeared. Müller had experienced air attack on the Eastern Front, had learned to recognize the sound of approaching aircraft, had developed the reflexes that meant survival. But the scale of American air power was something different. The sky filled with aircraft P-47s, P-51s, Typhoons, Thunderbolts attacking in coordinated waves, turning roads into kill zones and tank columns into funeral pyres. German armor scattered, seeking tree cover and concealment. Richter, Müller's driver, proved his skill repeatedly, finding covered positions seconds before rocket-firing fighters screamed overhead. The advance slowed, then stalled, then began to reverse. By December 22nd, Müller's unit was in tactical retreat, trying to preserve combat effectiveness while avoiding encirclement. And that morning, their Panzer IV's final drive failed. They were 10 kilometers behind what remained of the front lines, on a secondary road leading back toward German positions. The mechanical failure was not dramatic, just a grinding noise. Then, complete loss of power to the right track. Richter coasted to the side of the road. Investigation revealed what they had feared for weeks. The final drive, worn by months of combat operations and inadequate maintenance, had finally given up entirely. Gefreiter Klaus Weber, the crew's loader and informal mechanic, estimated 6 to 8 hours for repair if they had the correct replacement parts. They did not have the correct replacement parts. They would need to cannibalize components from another Panzer IV, if they could find an abandoned one nearby, if that Panzer IV had not been stripped by other desperate crews trying to keep their own vehicles operational. Müller sent Weber and the bow gunner, Gefreiter Paul Schneider, to scout for salvageable parts while he and the remaining crew established security. The forest around them was quiet in the way that meant danger. No birds, no movement, just snow falling through bare branches and the distant rumble of artillery. The Americans were somewhere ahead, probably closer than German intelligence estimated. Weber and Schneider returned 90 minutes later, breathing hard, with news that changed everything. Half a kilometer north, Weber said, American position. Abandoned, maybe 6 hours ago. Infantry pulled out, left everything, including a tank. What kind? Müller asked, though he already suspected. Sherman, M4. Looks intact, engine cold but no visible damage. The tactical situation was clear. They were 10 kilometers behind collapsing German lines with a disabled Panzer IV. Repairing their own tank would take hours they did not have, assuming they could even find the parts. Walking out meant abandoning their vehicle and all their equipment. But an American tank, already fueled, and presumably operational. "Could you start it?" Müller asked Weber. "Probably. They're simple machines. But Herr Oberfeldwebel, we can't—" "Can't what?" Weber gestured helplessly. "Drive an American tank? Through German lines? They'll shoot us before we can identify ourselves." It was a legitimate concern. German anti-tank crews were trained to shoot first at unidentified armor, and a Sherman would be very unidentified. But Müller was already calculating. The alternative was capture or death. At least in a functioning tank, they had mobility, protection, options. "We paint crosses on it," Müller said, "big ones. White paint from the maintenance kit. We drive slowly, we use signal flags, we identify ourselves continuously. Yes, it's a risk, but staying here is certain disaster." The crew looked at each other. These were men who had survived 3 years of war by making hard decisions quickly. Richter nodded first, then the others followed. They stripped their Panzer IV of everything portable ammunition, personal equipment, tools, the Enigma coding materials that would mean execution if captured with them. Müller set demolition charges to destroy the disabled tank and its sensitive equipment. Then, they moved through the snow toward the American position. The Sherman sat exactly where Weber had described it, in a clearing that had been an American motor pool. Foxholes ringed the perimeter, hastily abandoned. Equipment lay scattered: ration boxes, ammunition crates, jerry cans. The Americans had left in a hurry, probably under artillery fire, taking only what they could carry. The tank itself looked surprisingly small. Müller had seen Shermans before in intelligence photographs, through his commander's optics, but never up close. After years in a Panzer IV, the M4 seemed almost delicate. Lower profile, certainly, but also somehow less substantial. The armour was clearly thinner. The track design looked crude compared to German engineering. The welds were rough, almost agricultural in quality. Weber climbed onto the tank and opened the commander's hatch. "Americans were using it as a command post, I think. There's maps, radio equipment, papers." He disappeared inside, and Müller heard him moving around, familiarizing himself with the layout. "Can you start it?" Müller called. "Looking for the button now. Everything's labelled in English, but—" There was a pause, some mechanical sounds, then the sudden roar of an engine firing up. Weber's head appeared in the hatch, expression somewhere between surprised and disturbed. "That's it. Push button. Just push the button." It started. Müller climbed up and looked inside. The interior was shockingly spacious compared to a Panzer IV. The crew positions were spread out, almost comfortable. Everything was painted white, clearly visible even in low light. Controls were labelled with simple English words and obvious icons. The gun controls looked like something from a tractor, straightforward mechanical linkages with no subtlety. "This is what we've been fighting?" Schneider asked, peering in from the loader's position. "It's like a workshop inside. Nothing is complicated." Weber was studying the driver's position with the expression of a man confronting something that violated his understanding of how the world worked. "The transmission is automatic. Automatic. Look, there's no clutch pedal. You just move the lever. That's it." For men trained on the complex manual transmissions of German tanks, this seemed impossible. A tank transmission required skill, required understanding of gear ratios and engine loads and synchronization. You couldn't just move a lever, except apparently, in American tanks, you could. They spent 20 minutes familiarizing themselves with the controls while the engine ran at idle. Weber discovered that the Americans had left the fuel tanks nearly full. They hadn't expected to abandon the position. Müller found operational manuals in English, which none of them could read fluently, but the technical diagrams were clear enough. The maintenance section of the manual was startlingly brief compared to German equivalents. The electrical system diagram occupied a single page. Using paint from their abandoned Panzer IV's maintenance kit, they painted large white German crosses on the Sherman's hull and turret. Not regulation markers, but crude emergency symbols that might convince German anti-tank crews to hesitate before firing. Müller tied a white panel to the radio antenna as an additional recognition signal. It was the best they could do. The drive back toward German lines was among the most stressful hours of Müller's war. They moved slowly, constantly buttoned up, expecting at any moment to take fire from their own forces. Twice they encountered German infantry positions and had to halt while Müller identified himself, standing in the commander's hatch with his hands visible, shouting credentials and unit designations until suspicious. Lancers accepted that the Sherman flying German markings was actually crewed by Germans, but the tank itself ran flawlessly. Richter, at the driver's position, kept muttering observations that became increasingly disturbed. The shifting is automatic, the steering is easy, the visibility is better than our tank. This isn't supposed to be better. They reached German positions near Stavelot as darkness fell on December 22nd. Müller reported to his battalion commander, Major Wilhelm Hartmann, and explained the situation. Hartmann was a veteran of the French campaign, a skilled officer who understood that this war was being lost but still fought it with professional competence. "You captured a Sherman," Hartmann said, studying the tank in the gathering darkness. "And you want permission to continue operating it?" "Herr Major, our Panzer IV is destroyed. This tank is operational, and we have fuel for it, until replacement vehicles arrive. Replacement vehicles are not arriving, Müller. You know this." Hartmann walked around the Sherman, touching the armor, examining the tracks. Strange feeling, isn't it, looking at American equipment up close? Not quite what the intelligence assessment suggested. "No, Herr Major. How does it drive?" Müller hesitated, then decided on honesty. "Better than I expected." Hartmann smiled without humor. "I've been reading captured American maintenance reports. Do you know what their operational availability rates are? 70 to 80% of their tanks are mission capable at any given time. Our rates are below 40% and falling. They attribute this to superior maintenance. We attribute it to simpler machines. Perhaps we are both correct." He lit a cigarette, the match flare bright in the darkness. "Very well. Keep it. Use it. When it breaks down, and American tanks do break down, Müller, don't romanticize the enemy. We'll find you something else." The Sherman did not break down. If you're finding this deep dive fascinating, please hit that subscribe button and ring the notification bell so you don't miss future videos exploring untold stories from history. Over the next 6 days, Müller's crew drove that Sherman across 200 kilometers of Belgian winter. They fought rear-guard actions against advancing American forces. They conducted reconnaissance patrols. They supported infantry positions. They evacuated wounded when no other transport was available. And every morning, Weber pushed the starter button, and the Continental R975 radial engine started on the first try. This should not have been remarkable. This was what engines were supposed to do, start when required. But by late 1944, getting a German tank engine started on a winter morning had become a significant accomplishment. The Maybach engines required careful priming, precise choking, sometimes external heating of the oil before starting was even possible. Crews developed elaborate cold start procedures. Sometimes it took 30 minutes of preparation to get an engine to fire up. The Sherman's engine just started. Cold, warm, didn't matter. Push button, wait 3 seconds for the starter to engage, listen to the engine, catch and settle into a rough idle. Every single time, the simplicity extended to everything. When the track threw a connector pin, a common failure mode that Müller had dealt with dozens of times on German tanks, they repaired it with basic tools in under an hour. On a Panzer IV, the same repair would have required the full maintenance kit, possibly a workshop, definitely several hours of skilled labor. The Sherman's track design was crude, but that crudeness meant it was also robust and easy to fix. The suspension required no maintenance. The transmission required no adjustment. The electrical system had circuit breakers instead of fuses. When something overloaded, you just reset the breaker. The cooling system was simple air cooling with no complex radiators to leak or hoses to burst. Everything about the machine reflected a design philosophy that prioritized operational simplicity over theoretical performance. Krauss, the gunner, spent a day familiarizing himself with the Sherman's 75mm gun and came away disturbed by what he found. "It's adequate," he reported to Müller. "The optics are inferior to our Zeiss equipment. The gun-laying mechanism is crude, but it works. And Herr Oberfeldwebel, the ammunition storage, have you seen how much they carry?" Müller had seen. The Sherman carried 90 rounds of 75mm ammunition compared to the Panzer IV's 87. But more significantly, the ammunition was stored in protected racks with water jackets, with blowout panels designed to vent explosions away from the crew. German ammunition storage was more compact, more efficient in terms of space utilization. But American storage was designed around crew survival. They built this tank expecting it to be hit, Krause said quietly. Everything about it says they knew their crews would take fire, would be penetrated, would need to survive and escape. Our tanks are built to win engagements. American tanks are built to be destroyed and have the crew walk away. It was an uncomfortable observation. German engineering optimized for performance. American engineering optimized for what happened when performance failed. On December 24th, Müller's unit attempted to establish a defensive position on a ridgeline overlooking a main supply route. They had 3 operational tanks, Müller's Sherman, and 2 Panzer IVs that had managed to remain functional. The mission was simple: hold the position for 24 hours, while German forces attempted to consolidate a new defensive line further east. American armored reconnaissance probed the position throughout the day. Skirmishes erupted, brief and violent, then faded as both sides maneuvered for advantage. Müller's crew fought their Sherman like a German tank, using terrain and cover, applying the tactical doctrine Müller had learned over 3 years of combat. The American tank performed adequately. Not brilliantly, the armor was thin, the gun merely serviceable, but adequately. By evening, both Panzer IVs had been withdrawn, with mechanical failures. One had thrown a track, the connecting pins on the guide teeth shearing under stress. The other had a transmission failure, third gear stripping out after the driver forced a shift. These were not uncommon failures. They were the kind of mechanical issues that happen to precision machinery under combat stress. Repair would take time, parts, expertise. Müller's Sherman continued operating. As darkness fell on Christmas Eve, Müller sat in the commander's position, monitoring the radio, and confronted what he had been avoiding acknowledging for 6 days. This American tank, this crude mass-produced machine, was superior to his Panzer IV. Not in the ways he had been trained to measure superiority. Its armor was thinner, its gun was less powerful, its optics were inferior, but in the only measurement that actually mattered, its ability. To keep fighting, it was vastly better. The Panzer IV was a more sophisticated machine. Its engine was more advanced, its transmission was more elegant, its suspension was more refined. But sophistication had become a liability. Every complex component was another potential failure point. Every tight tolerance was another mechanism vulnerable to mud or cold or wear. Every hand-fitted part was irreplaceable when it broke. The Sherman was crude, but its crudeness was a form of genius. Large tolerances meant components could be dirty and still work. Simple systems meant repairs required no special expertise. Standardized parts meant anything could be replaced. Robust designs meant things rarely broke in the first place. The Americans had not built a better tank by German standards. They had redefined what better meant. Weber articulated it one evening during maintenance. "It's like tools, Herr Oberfeldwebel. A German watch is beautiful, precise mechanisms, tiny gears, perfect finishing. But a hammer is useful. Americans built hammers." Schneider, cleaning the Sherman's machine gun, added, "And they built thousands of hammers, all identical. all functional, all with spare parts available. We built a few hundred watches, each one slightly different, each requiring specialized knowledge to repair. Are we saying American engineering is superior? Richter asked quietly. Muller considered the question carefully. I think we're saying that American engineering is appropriate. They designed for their capabilities and circumstances. Mass production, vast resources, moderate skill levels. They built what they could build in the numbers they needed. We designed for excellence at small scale. The problem is that modern war requires excellence at large scale. It was a devastating admission. German engineering culture, the pride in precision, the emphasis on sophistication, the assumption that quality could compensate for quantity had led Germany to build magnificent machines that lost the war. American engineering culture, practical, focused on availability and reliability, had led America to build crude machines that won. On December 28th, Müller's unit received orders to fall back to new positions near St. Vith. The Ardennes offensive had failed. German forces were in general retreat, trying to preserve as much combat power as possible while avoiding encirclement. The roads were clogged with vehicles retreating armor, supply trucks, horse-drawn artillery that seemed to belong to a different century. Müller's Sherman had now been in continuous operation for 12 days and had covered approximately 350 kilometers under combat conditions. Weber calculated that they had started the engine perhaps 60 times. It had started successfully every single time. They had conducted one field maintenance session, changing the oil and air filter, tasks that took 90 minutes with basic tools. The track had required adjustment twice 20-minute procedures. That was the complete maintenance history of an American tank operating under winter combat conditions. Herr Oberfeldwebel, Richter said during a halt, I've been thinking about what we learned, about the Sherman, about their design philosophy. And? I think we've been measuring the wrong things. We measured gun penetration, armor thickness, maximum speed. These are numbers. They're easy to compare. But we never measured time between failures. We never measured maintenance hours per operational hour. We never measured how many roadside repairs a crew could perform without specialist support. Americans measured those things. They designed for those metrics. And those metrics determine who can sustain combat operations. Krauss had been listening. It means the intelligence assessments were wrong. Not in their facts, American armor is thinner, their guns are less powerful, but wrong in what they concluded from those facts. They concluded American tanks were inferior. They should have concluded American tanks were different, optimized for different priorities. Priorities that matter more than the ones we chose, Weber added. It was one of the strangest conversations Müller had ever had with his crew. German soldiers, in an American tank, discussing the fundamental failures of German military-industrial philosophy while retreating from a failed offensive. The conversation was possible because they were beyond hope, beyond propaganda, beyond careers or consequences. They were simply trying to understand how everything they had believed had turned out to be wrong. By early January 1945, Müller's Sherman had covered over 600 kilometers. The engine still started every morning. The transmission still shifted smoothly. The tracks still pulled the tank forward through mud and snow. Weber maintained a log of maintenance actions, partly from German thoroughness and partly from a kind of horrified fascination. The log showed oil changes every 200 kilometers, track adjustments as needed, replacement of one road wheel, bearing a 15-minute job, and various minor issues. Total maintenance time, perhaps 12 hours across 3 weeks of combat operations. A Panzer IV operating under similar conditions would have required 2 to 3 hours of daily maintenance. The math was brutal. For every operational hour, German tanks consumed maintenance hours at a rate that made sustained operations impossible. American tanks consumed maintenance hours at a rate that made continuous operations routine. The implications extended far beyond individual vehicles. Tank units needed to remain operationally available to be effective. A division with 90 tanks, 40 of which were operational at any given time, had fundamentally different capabilities than a division with 90 tanks, 70 of which were operational. Numbers mattered, certainly, but operational. Availability was the multiplier that transformed numbers into combat power. American tank divisions maintained 70 to 80% availability because their tanks required minimal maintenance and repairs, could be performed by crews without specialized knowledge or tools. German tank divisions struggled to maintain 40% availability because their tanks required constant attention and repairs demanded expertise and parts that were increasingly unavailable. "We designed for craftsmen," Muller said during one evening discussion. "They designed for conscripts. We assumed skilled crews and well-equipped workshops. They assumed moderate training and field conditions. Our assumptions produced beautiful machines. Their assumptions produced functional ones. The crew's respect for the Sherman had evolved from grudging acknowledgement to something approaching reverence. Not because it was a magnificent machine, it was not, but because it did what it promised to do, day after day, without complaint or drama. It started, it ran, it fought, it survived. These seemed like modest virtues until you had spent years fighting in tanks that failed to deliver even these basics consistently." Krause made an observation that captured something essential. American tanks are honest. They don't promise performance they can't deliver. A Sherman's armor is thin, but the armor is exactly as thick as specified, everywhere, consistently. The gun is adequate, and it performs adequately, reliably, every time. Germans built tanks that promised excellence and delivered excellence when everything worked perfectly, which was rare. Americans built tanks that promised adequacy and delivered adequacy even when nothing worked perfectly, which was always. On January 8th, Müller received orders to report to a rear area collecting point where surviving units were being reorganized. The Ardennes offensive had cost Germany approximately 800 tanks and assault guns, either destroyed in combat or abandoned due to mechanical failure or fuel shortage. The Americans had lost similar numbers, but would replace them within weeks. Germany's losses were irreplaceable. The drive to the collecting point took 2 days through roads clogged with retreating German forces. Müller saw the full scope of mechanical devastation. Panthers abandoned with transmission failures, Tigers immobilized by track problems, Panzer IVs awaiting spare parts that would never arrive. The roadside wrecks were not primarily victims of American guns. They were victims of their own complexity, defeated by engineering decisions made years earlier in design bureaus in Stuttgart and Kassel. At the collecting point, a major from the Ordnance Department interviewed Müller about his experiences with the captured Sherman. The major was professional, taking notes, asking technical questions. When Müller finished his report, the major was quiet for a moment. "We've received similar reports from other units that captured and operated American equipment," the major finally said. "The pattern is consistent. Their equipment is crude by our standards but remarkably reliable. This contradicts most of our pre-war assumptions about American industrial capabilities. Will this information change future designs?" Müller asked. The major smiled without humor. "Oberfeld-Webel, there are no future designs. The war is ending. We are simply attempting to understand what happened." He paused, considering. "I've read reports from engineers who inspected American factories. One described the Sherman production line as resembling a locomotive factory more than a traditional armory. Standardized components, modular assembly, minimal hand fitting. The engineer's report concluded that American methods sacrificed quality for quantity. I suspect that conclusion will require revision." "They didn't sacrifice quality," Müller said. "They redefined it. Quality isn't achieving perfect specifications in ideal conditions. Quality is maintaining adequate specifications under terrible conditions." "Yes," the major said. "That is exactly the lesson we failed to learn until too late." Before you leave, let me know in the comments, What historical misconceptions do you find most interesting? And if you enjoyed this deep dive into engineering philosophy and military history, hit that subscribe button and check out our other videos exploring the unexpected truths behind famous conflicts. Müller's Sherman was confiscated for technical evaluation in mid-January. He watched it being driven away by a test driver, heading for some facility where engineers would disassemble it and study its construction. He felt an odd sense of loss. That tank had kept him and his crew alive through some of the worst combat of the war. It had taught him things he wished he had never needed to learn. The crew was reassigned to a rebuilt Panzer IV 2 days later. The new tank was fresh from the factory, properly maintained, with all systems functioning to specification. It should have felt like a homecoming. Instead, it felt like a step backward. The Maybach engine required 30 minutes of cold start procedure on the first morning. The transmission needed careful shifting technique. By evening of the first day of operations, Weber had already logged 2 hours of maintenance. "It's a good tank," Richter said, but without conviction. "It's a German tank," Krauss replied, which seemed to say everything necessary. They fought that Panzer IV through the final months of the war, through the retreat across Germany, through the final desperate defences. The tank broke down repeatedly. They repaired it repeatedly, sometimes with proper parts, more often with improvisation and determination. It was, in its way, magnificent, a triumph of precision engineering and sophisticated design. It was also obsolete, not because its specifications were inferior, but because its design philosophy was inappropriate for industrial warfare. Years after the war, in the late 1950s, Müller attended a technical conference in Munich. He had become an engineer, working for a firm that manufactured diesel engines for industrial applications. The conference included a lecture by an American engineer named Robert Morrison, who had worked on Sherman tank development during the war. Morrison showed photographs of Sherman production lines, explained the design philosophy, discussed the decision-making process behind American tank development. Müller listened with the intense focus of someone hearing secrets that explained his own past. During the question period, Müller identified himself and asked, "Were you aware that German crews considered the Sherman mechanically crude?" Morrison smiled. "We were aware. Some American crews thought the same thing, especially those who had to fight Tigers and Panthers. But crude was not an insult to our design team. It was a deliberate choice. We could have built more sophisticated tanks. We had excellent engineers. But sophisticated tanks have sophisticated failure modes. We needed tanks that farm boys from Iowa could maintain with basic tools. We needed tanks that would still function after weeks without proper maintenance. We needed tanks that could be mass-produced by workers with minimal training. These requirements led to designs that looked crude to European eyes. But they were exactly as sophisticated as they needed to be, no more, no less. Would you have designed them differently if you had known how reliable German tanks were expected to be?" Müller asked. Morrison considered the question carefully. "Oberfeldwebel Müller, it's still Oberfeldwebel in your mind, isn't it?" "I think the question is backwards. We didn't design around German capabilities. We designed around American industrial reality and military requirements. Your engineers designed beautiful machines for a war they imagined short, decisive, relying on small numbers of highly trained crews. Our engineers designed adequate machines for the war we actually fought, long, grinding, requiring vast numbers of moderately trained crews. Your engineers were more talented. Ours were more appropriate. It was," Müller reflected, "the most devastating compliment he had ever heard about German engineering. You were more talented. But talent was not enough." The conversation continued during the conference reception. Morrison asked about Müller's experience with the captured Sherman, listened to the account, took notes. At one point he said something that Müller never forgot. The Sherman was not a great tank. It was barely an adequate tank. But it was an appropriate tank, and in war, appropriateness matters more than greatness. You can't supply greatness to 10,000 crews simultaneously. You can supply adequacy, and 10,000 adequate tanks that keep running will defeat 1,000 great tanks that keep breaking. Müller shared a story he had never told before about the December morning in Belgium when his crew first started the Sherman's engine, about Weber's shocked expression at the simplicity of the push-button start, about their growing realization over those 12 days that everything they had believed about American industrial capability was wrong. Morrison listened intently. You know what's interesting? We received similar feedback from our own crews. The British gave us Lend-Lease Shermans and complained they were crude compared to their Churchills. The Soviets compared them unfavorably to 34s. Everyone was accustomed to more sophisticated designs, but by war's end, everyone wanted more Shermans because they worked. Not because they were brilliant, but because they were reliable. Do you think German engineers could have learned this lesson earlier? Müller asked. No, Morrison said immediately, because the lesson contradicts everything engineering schools teach. We teach that excellence comes from precision, sophistication, optimization. Your engineers followed that teaching to its logical conclusion. They built extraordinary machines. But war doesn't reward extraordinary machines. It rewards adequate machines that exist in sufficient numbers when needed. That's a brutal lesson that violates engineering aesthetics. Nobody learns it willingly. As the conference ended and attendees dispersed, Morrison gave Müller his business card. If you're ever in Detroit, look me up. I'd like to hear more about your experiences. There's a book I'm considering about design philosophy and military effectiveness. Your perspective would be valuable. Müller never made it to Detroit. Life intervened career, family, the ordinary demands of rebuilding in post-war Germany. But he kept Morrison's card for the rest of his life, a reminder of a conversation that had given meaning to experiences he had struggled to understand. In his final years, Müller sometimes spoke to engineering students about his war experiences, not about combat that was for veterans' gatherings, not classrooms, but about design philosophy, about the difference between theoretical excellence and practical effectiveness, about the danger of optimizing for the wrong metrics. He would tell them about the December morning when his Panzer IV broke down and his crew captured a Sherman, about the 12 days that followed when that crude American tank taught them lessons they wished they had learned years earlier, about the fundamental error of confusing sophistication with superiority, precision with effectiveness. German engineers in 1940 were the finest in the world, he would say. Our mistake was assuming that being the finest engineers meant we would build the finest weapons. But war is not an engineering competition. It is a test of systems, industrial systems, logistical systems, training systems. The best weapon is not the most sophisticated one. It is the one that functions when you need it, that your soldiers can operate, that your factories can build, that your supply chains can sustain. The Americans understood this. We did not. That difference decided the war more surely than any battle. Students would sometimes challenge him, citing the technical superiority of German designs. He would nod patiently and respond, "Yes, German tanks had better armor, better guns, better optics, and we lost. If those advantages had mattered the way we thought they did, we would have won. We lost because we optimized for performance while Americans optimized for availability. Their tanks were available, ours were not. In war, advantage belongs to the side that can sustain operations, not the side with the best engineering specifications." The lesson applied far beyond tanks, beyond war, even beyond engineering. It was about understanding the difference between what looks impressive and what actually works, about the danger of cultural assumptions masquerading as objective analysis, about the necessity of questioning whether you are solving the right problem, not just solving the problem elegantly. Müller died in 1989, a few months before the Berlin Wall fell. His obituary in the local paper mentioned his war service, but focused on his post-war career as an engineer, his contributions to diesel engine design, his decades of teaching, There was no mention of the Sherman tank he had captured and operated for 12 days in Belgium, but his former crew members attended his funeral. Weber, Richter, Krauss, Schneider, those who had survived the war. At the reception afterward, they shared memories, not of combat, but of that strange interlude in December 1944 when they had operated an enemy tank and learned truths they had not wanted to know. He understood what it meant, Weber said. That experience with the Sherman, most of us just saw it as chance, captured equipment during a retreat. Kurt understood it as evidence of something larger, that we had been wrong about fundamental things. That the war was lost not just tactically but philosophically. He never stopped thinking about it, Krauss added. Even decades later, he'd mention it. We built for perfection, they built for adequacy. It haunted him, I think, the realization that our excellence had been a liability. Schneider, who had become a teacher after the war, reflected, "What haunts me is wondering if we could have learned those lessons earlier. If our engineers had visited American factories before the war, seen their methods, understood their philosophy, would we have changed our approach? Or would we have dismissed it as crude, the way we dismissed everything American?" The conversation faded as the reception ended. The surviving crew members went their separate ways, back to their lives in the post-war world, but they carried with them that shared experience from December 1944, when an American tank had taught them that the side with the best engineering does not necessarily win, that sophistication can be a weakness, that the crude solution that works is superior to the elegant solution that fails. The Sherman tank they had captured was probably scrapped decades ago, melted down and recycled like most war materiel. Müller never learned what happened to it. But in a sense, that specific tank did not matter. What mattered was what it represented: a different approach to engineering problems, a different set of priorities, a different understanding of what war demanded from machines and the men who operated them. In the end, that captured Sherman had covered over 800 kilometers under combat conditions before Müller's crew was separated from it. It had started reliably every single morning. It had required minimal maintenance. It had kept 5 German soldiers alive during one of the most desperate periods of the war. It had been, by any objective measure, a good tank, not because it was sophisticated or elegant or impressive, but because it did what needed to be done when it needed to be done, without drama or failure. That was the lesson. Simple, brutal, undeniable. Excellence that doesn't function when needed is not excellence. Adequacy that works consistently is superiority. The Americans had understood this. The Germans had not. And in the frozen forests of Belgium in December 1944, that difference between philosophy and practice had been written in the contrails of abandoned German armor lining every road, while crude American tanks kept rolling forward, starting every morning with a single button press, fighting every day without complaint, winning not through brilliance but through reliability. If this story moved you or gave you new perspective on history and engineering, I'd really appreciate it if you'd subscribe to the channel. We work hard to uncover these lesser-known stories that change how we understand pivotal moments in history. Thanks for watching, and I'll see you in the next video.